So guys, today we're going to be looking at kinematic equations to solve one-dimensional motion. The main four that we have are these guys here. This is equation 1, 2, 3, and 4. All right, this equation is this guy just rearranged in a certain way. Now, I've already written the equations that you're going to be using for these problems, so you don't have to guess through it, but we're going to explain why you would pick these ones. So a couple different things that you want to maybe write down, because they're kind of important, / notes here. So A, that is acceleration. So when we have to solve for something, it's going to be the symbol A. And the unit for acceleration is the meter per second squared. In all these problems, we need our units to be in meters per second squared, and time we need it to be in seconds. So V sub I, that is your initial velocity. Okay, it's velocity or speed here. We have meters per second. Final velocity will be V sub F. Now, for this, we're going to use distance and displacement kind of simultaneously. All right, so distance / displacement. And that unit will be in the meter. And then T, time, will be in seconds. Okay, other two things that are very useful pieces of information. Okay, if something starts at rest, that's pretty much going to tell us that our initial velocity is 0. Okay, and then if it comes to a stop, final velocity will equal 0 meters per second. So you want these pieces of information, guys, because there will be sometimes little hidden pieces of information in a problem. Okay, like a car waiting at a stoplight. Okay, gets up to it may just say a car waiting at a stoplight gets up to a speed of 30 meters per second in 10 seconds. What is the acceleration? Well, they didn't tell me the initial velocity. You've got to use some context clues and some real life knowledge and background information that you have on a subject to be able to kind of put those things together, interpret it in the correct way. Now, let's begin. Here it's telling us a sports car accelerates from rest to 26.8 meters per second, roughly 60 miles an hour. Now, is this right here in parentheses, is that going to be pertinent to us? Like, is that going to be important? Do you think? It could be, but we want everything in what units again? Meters, seconds, meters per second, and meters per second squared. So this mile per hour, not going to help us out right here. It's just kind of giving you a heads up like, oh, well, about 60 miles an hour would be somewhere around 26.8 meters per second. Okay, so we're not going to really need that. It tells us it's going to happen in 5.1 seconds, and they want to know what is the acceleration. So this is how I want all your problems completed. You're going to label and write down all of the variables given. So your acceleration, we don't know. That's your question mark. It starts from rest. So from rest, initial velocity is going to be 0. and it gets up to a speed of 26.8 meters per second. And it does so in how much time? Time of 5.1 seconds. So how you would do this if this wasn't here right now? If this equation wasn't here right now, you would have to look at your equations at the top and figure out which one you would need to use. You need the equation that has, all right, all four of these variables. So if we took a look, all right, we have VF, time, VI, and acceleration. Here we have no time, so we can't use this one. We have time, we have acceleration, we have VI, there's no VF, so we can't use this one. We have a VI, VF, and a T, but there's no acceleration, so we can't use that one. We're left here with the one that I labeled equation 1. So this right here, this is equation 1 just reworked. Now, you don't necessarily need it done like that. You don't need it done like that. So I can show it like this. If you wrote it out, VF is equal to VI plus AT. And then once you know what equation you're using, you're going to put those numbers, okay, in the correct spots. So my VF I have is 26.8 equals initial velocity is 0. Bring down your plus sign. We don't know what A is, so that remains A. And we have a time of 5.1 seconds. All right, and then we're basically going to just use some little math operations in order to solve for a missing piece. So to get rid of this guy, if there was an actual number, you got to subtract it from both sides. Since it's 0, we don't have to do anything. So I'm just going to simplify this a little bit. So we have 26.8. Now, if you move this 5.1 to the left of A, it's okay, or you can keep it on the right. So some people like to see, like, oh, we were talking about a math problem and it was like 3x equals 9. They like to have, all right, the variable on the right of it. Here, if it's on the left, it's fine. It's not going to freak you out, but I'm just going to write it like this, 5.1a. To get a by itself, what would I do? Well, to get 3x by itself, you got to divide both sides by 3 to get x. Same principle applies. Here, you're going to have to divide by 5.1, both sides. And then we just plug it into the calculator. 26.8 divided by 5.1. 26.8 divided by 5.1. And it kicks out an answer of 5.2549. I'm going to cut it off here at 2 decimals. And so we were going to be looking at 5.25 meters per second squared for our full unit. Problem number 2. All right, kid goes down a slide starting from rest. That's an important piece of information. The length of the slide is 2 meters, and it takes the kid 3 seconds to reach the bottom. What's the acceleration? So they want acceleration. Originally, I'm at rest. The length of the slide, even if you weren't sure, okay, from what we wrote down before, what unit has meters in it, it's our distance or displacement. And so that is going to be letter D of 2 meters. And they give us a time here of 3 seconds. That's it. That's all the information. There is no VF. So if this equation wasn't there to tell you this is the one to use, again, how do you go about it? You have to look at the 3 or 4 variables you're given or you determine that are used in the problem, and then go up to the list. So what equation has both A, VI, D, and T in it? Well, there's no D in this one, so we can't use that. All right, this one has a D, it has A, it has VI, but we don't have a VF, and we don't have time. We can't use that one. Okay, we have VI, T, we have D. There's no A in this one, so we can't use that. We have D, we have VI, we have T on both sides here, and we have A. So we're going to be using equation 3. So again, process, guys, still going to be the same. Rewrite the equation. VI times time plus 1/2 AT squared. And then we're going to just plug in all of our information. Do we have D? Yes, we have it. It is 2. So we're going to drop a 2 there. Bring down the equal sign. Do we have an initial velocity? Well, they told us it was 0. And I'm going to multiply that by whatever the time is of 3 seconds. Bring down the plus sign. And then we're going to bring down the 1/2. Do we have A? No, that's what we're solving for, so we're going to leave A, B. I'm going to actually draw it like this for right now, for this time being. All right, our A. And we said that T was 3 seconds. Now, it's important that you note that in this right here, you're only squaring time. You only square time. So T is 3 seconds, and we have to square that. So I'm going to, again, I'm going to show you guys step through step. I'm not just going to cut out. All right, anything here, 2. This is going to be 0. Bring down the plus sign, and we have 1/2 A times 3 squared, which is 9. So there can be 2 ways at which you do this. You can basically just take 1/2 of whatever the time is, which is 4.5. So you'd have 4.5A is equal to 2. Or you can do, to get rid of this 1/2, you can multiply both sides by 2. The 0 doesn't do anything because it's 0. And then this would become a 4. And then you have this times 2 gets rid of this piece here. And then you have 9A. To get A by itself, you have to divide both sides by 9. And so acceleration is going to equal 0.44 repeating, and the unit will be in meters per second squared. Now, the only other one that may have any kind of pain in the butt to it might be number 5. So let's take a peek at number 5. So a driver notices that an upcoming speed limit changes from, remember, we don't want to use miles per hour. All right. We want it in meters per second. So 45 miles, nope, we want to use the meters per second. So we're moving at 20 meters per second, and we're getting to, or have to slow down to 11. Now, if you estimate the speed change is going to be at 50 meters, what acceleration is needed to hit, all right, in order to reach this new speed limit before it begins? So let's break down everything we are given. We're given an initial velocity of 20 meters per second. We're given a final velocity of 11 meters per second. And there's no time, but they give us 50 meters here, which is your distance or displacement. And then what are they asking? What acceleration? So acceleration is going to be your question mark. Okay, so again, how you would have to do this: use your variables given, find the equation on the front side that has all four. Again, I already wrote that equation here that has VF, VI, A, and D. So VF squared is equal to VI squared plus 2AD. And now let's solve and put everybody in the correct spot. What is our VF? It is 11. So we have to do 11 squared. What about initial velocity? What is our initial velocity?
Hi, how are you?
Good.
My friend here? No. Nice.
No, sir. Initial velocity, 20 meters per second. So we have to put this here. And remember, you're only squaring, the individual pieces here. Plus sign comes down. This pencil's killing me here. Bring down the 2 because that's part of the equation. We don't know what acceleration is, so we're going to leave that put. And what are we going to write for D? Well, 50. All right, and now you guys are going to start to, all right, simplify this down. 11 squared, 121. 20 squared becomes 400. And then we have, what's 2 times 50? 100. So I can do that. I can do this. I can double whatever the distance is. So if I do 2 times 50, that would be 100A. Okay, now we got to simplify. I want 100A on this side by itself. So what do I got to do with the 400? Yep, you got to subtract it. And whatever you do to one side, you have to do the other. So got to subtract both sides by 400. So the 400 minus 400, we'll basically say, see you. 121 minus 400 gives us negative 279. And then that will leave us with 100A. So to get A by itself, correct, you are going to divide both sides by that 100. And that will get A by itself. And now A is going to be a negative 2.79, and the unit for acceleration is meters per second squared. So these problems, guys, are really going to come down to breaking down a problem, all right, reading a problem and breaking down the information that's given, okay, and making sure that they're correct and who's initial, who's final, whether you have distance, time, acceleration. What equation has the 3 or 4 variables that you need in it, okay, writing the equation out and then putting, all right, our information underneath the spots where they belong, and kind of just doing the math. The only other thing was in number 6. Can someone tell me, what are we given? 1 minute after takeoff, a rocket carrying a space shuttle into outer space reaches a speed of 447 meters per second. What was the average acceleration of the rocket during the initial minute? So, what do they give us?
Speed
Which speed?
of the of the spaceship.
Okay. So, they say the spaceship reaches the speed of that. So, when it says reaches the speed of, got to use your context clues. Basically, that's telling you that it got up to that. So, what would that be? Initial or final speed?
Wait, final.
Yeah, final, because that's what it got up to. So right there, guys, VF is 447 meters per second. So when you're looking at this problem, there's only one actual number given. The rest is, I don't see any other numbers, do you? So that confuses some people. Well, think about it. How many people have ever seen just like at least a video of a space shuttle launching? Right? They're usually like 3, 2, 1, blast off. Well, what is it doing before blast off? Is it's standing still, right? There is no speed. So you have to use your context clues there, right? So like after the takeoff. So your initial velocity, 0 meters per second. So even though it wasn't listed here as a number, you're going to need to use your context clues, right? If a plane is going to be taking off down a runway. How many people have been on an airplane before? All right, before they hit the throttle, all right, in order to gain enough speed to take off, you're usually just sitting at the very back end of the runway. And they're waiting for the tower to clear them, and then, all right, they start to accelerate. In which case the initial velocity would be 0. Okay, what else do they give us? I don't have a distance in here. What do they want? They want an acceleration. Well, what else? I need something else. Do they give me a time?
No.
They do. What is the time?
Yeah.
So they tell us it's 1 minute. Now, I had a couple guys do this problem before in my other class, and they were not getting to the correct number, and the reason was their units didn't match. So meters per second, it's not meters per minute. All right, our acceleration is meters per second squared, not meters per second per minute. All right, so we need to make sure that our time is in seconds. So in 1 minute, there are 60 seconds. So that would be the time that is needed. So you look on the front side for the equation that has VF, VI, A, and T. All right. Boom. This guy right here, first one. VF, VI, A, and T. And VF plus AT, and we finish by putting everybody in. So 447 equal to 0 plus A times T, which is 60. So the 0 doesn't do anything, so you're pretty much doing 447 is equal to, right, 60A. To get A by itself, divide both sides by 60. And you are going to have an acceleration of about 7.45 meters per second. Is that the right unit? No. Acceleration is meters per second squared.